Hey, welcome back. Mr. P helps with Algebra 2. This is Unit 2, Topic 1, SLT number 8. We're going to get into solving quadratic equations with complex solutions, which I think I may have even showed a couple examples of in prior videos. Start off with adding, subtracting complex numbers. You can only combine things that are the same, so real number with real number, and imaginary term with imaginary term. So negative 8 minus 2 more makes negative 10. And then 8i's minus 4i's makes positive 4i's. Over here, 8i's plus negative 8i's makes nothing. And then if I take away 7i's, then that's negative 7i's. So there's no real number here. Plus negative 4 makes negative 4. And negative 4 minus nothing makes negative 4 as well. All right, so real numbers first. There's no real number here. Real number plus negative 1 is negative 1. Just negative 1. There's no real number over here. Negative I plus negative 7i is negative 8i's, and negative 8i's minus 2 more i's makes negative 10i's. And here, real number. So 1 plus 7 makes 8. And then negative 6i's plus negative 5i's, or you can say negative 6i's minus 5i's makes negative 11i's. All right, getting into what we need to talk to. So we're going to start off with the basics. Just a review of multiplying. So multiplying radicals. Square root of 3 times the square root of 5 is square root of 15. Square root of 3 times the square root of 3 is the square root of 9, which is both positive and negative 3. So square root of anything squared basically eliminates and leaving you with whatever's on the inside. Same thing here, so square root of anything times itself, so 5 times 5 is square root of 25. Square root of 25 is both positive and negative 5. I times I is I squared, and I squared, as we talked about before, is negative 1. It's a real number. Negative 1i times another i makes negative I squared, and I squared is negative 1. The opposite of negative 1 is positive 1. 2i times 2i is 4i squared, and that's negative 4 because I squared is negative 1. Multiply. Negative 2 times 2 is negative 4i squared, so that changes to positive 4. I squared changes this to positive 4. All right, first, outer, inner, last. 2 times 2 is 4, minus 2i. Inner is positive 2i, and last is negative I squared. All right, so the negative 2i and positive 2i is going to cancel each other out. This is negative 1. Opposite of negative 1 is positive 1. Add 1 to the 4 at the beginning, and you've got 5. All right, so that kind of shows you how you would do these. And the whole point of this is to show you how when you have the same thing and one's minus and one's plus, then your outers and inners are going to cancel each other. So x times x is x squared. You're going to get plus 3x and minus 3x. Those are going to cancel. And then negative 3 times 3 is negative 9. So the answer is x squared minus 9 because the outers and inners canceled. Same thing would happen for all the rest. The only difference here is, you got an irrational times another irrational, which happens to be 2. All right, so skipping through that. So solving quadratics, the whole point is you can see that this is the same as this. And if I solve this, it kind of helps you how to factor. So it's going to help me how to factor this binomial here. So this gives me x equals both positive and negative 3. So over here, the factors are x plus 3 times x minus 3. X times x is x squared. The outers and inners will cancel each other out, and 3 times negative 3 is negative 9. Same thing goes here when it's irrational, so that means x is both positive and negative square root of 6. So this is x plus the square root of 6 times x minus the square root of 6. I know in Algebra 1 you probably talked about how this is not factorable because the difference of squares. It's not possible because this is an irrational number, but now that you're in Algebra 2 you can see that it is factorable, technically, by using irrational numbers. Square root of both sides, you get x equals positive and negative 5i. Remember it's 5i because this is a negative number. So there's your number. So you got x plus 5i times x minus 5i. Now, one has to be plus and one has to be minus in order for the outers and inners to cancel each other out. But the fact that this is plus 25, that's what caused it to be 5i. Because when you do last, 5 times negative 5 is negative 25i squared. And the I squared turns this last term into positive 25. So that's where the I comes in. The fact that this is plus meant you had to use I because you had to change this minus back into a plus. So this is also going to have I involved, and it's going to be the same thing. X equals both positive and negative square root of square root of 7, or I times the square root of 7. That's the same thing. So it's going to be x plus I times the square root of 7 times x minus I times the square root of 7. And once again, square root of 7 times square root of 7 is 7, and negative I times another I is I squared, negative I squared, so that changes it to the opposite. So that's the reason why it's plus. All right, so getting to, I have so many questions here to solve. I'm not going to do all of them, and I am already at 5.5 minutes in. Solve each equation by completing the square. I do want to show a couple examples. This is a good method. Once again, a reminder, good method when there's no leading coefficient, so there's no a term. Notice in all these questions, there's no a term. It's just p squared, just a squared. There's no number in front. And also notice that all of the b terms are all even numbers. If this was an odd number, I probably wouldn't use this strategy. I would use something else, because the formula is b divided by 2 squared. So if it can't be divided by 2 evenly, then you're going to be dealing with decimals. I'm not saying you can't do this method, it's just it wouldn't be the easiest method. So 14 divided by 2 is 7. 7 squared is 49. So I know that that's the number I need to add to both sides. Now, of course, I had to move the negative 38 to the other side, made it positive 38, and then adding 49 to both sides. 49 is what it takes to complete the square, and 38 was not 49, so I moved it to the other side, and I added 49 to both sides. Now, why? Because now it's got a perfect square of p plus 7. I know it's a perfect square because 7 times 7 is 49, and 7 plus 7 is 14. It's a perfect square. Add these two together, and you get, 87. And then you can solve it from there. Square root of both sides, you get p plus 7 equals square root of 87. I'm going to leave this like the way it is. Move the 7 to the other side, and you get p equals negative 7 plus or minus the square root of 87. There's your answer. Do one more example of this. Picking another question, I'll choose this one down here. So I'm going to move the c term to the other side, leave a little bit of room. Use this number right here. So negative 2 divided by 2 is negative 1, and negative 1 times itself is positive 1. Add 1 to both sides. That's what it takes to complete the square. It's now a perfect square of n minus 1 plus itself times itself equals 4. Now, this time it worked out perfectly. This is going to be a perfect square. So I get n minus 1 equals both positive and negative 2. Move the 1 to the other side, n is 1 plus or minus 2. So the answers are going to be 3 and negative 1 if I simplified. So I could simplify. So this will be 1 plus 2 makes 3, and 1 minus 2 makes negative 1. There's your two answers. Now, you could also get complex answers when you're doing quadratic formula. So notice in these questions, sometimes there is an a term. So this is the method I would use. So it's negative b plus or minus square root of b squared minus 4ac divided by 2a. So first thing you need to do is set the problem equal to 0. Well, this one, this one, and this one are all already set equal to 0. For all the other questions, I would need to move this 2 to the other side, which makes it 2a squared minus a minus 15 equals 0, because I took 2 more away. For this one, you would add 2 more, so this would become b squared minus 4b minus 12 equals 0, because I'm adding 2 to that number. Same thing goes for this one, so I'm moving the 18 to the other side. 8n squared minus 4n minus 18 equals 0. All right, so now once you got a set equal to 0, then you can just take your a, b, and c and plug it into the formula. So negative b, so the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c, all of that divided by 2 times a. All right, so the opposite of negative 5 is 5, plus or minus square root of negative 5 squared is 25. Negative 4 times 2 is negative 8. Negative 8 times 3 is negative 24. Now, I already know that I'm not going to get a complex solution in this case. And the reason I know that is because 25 minus 24 is a positive number. And anytime you have a positive discriminant, then you're going to have either 2 answers or 1 answer. Well, I guess if it's 0, you're only going to have 1 answer. In this case, I know I'm going to have 2 solutions. 2 real solutions, that is. 5 plus or minus 25 minus 24 is 1. Square root of 1 is both positive and negative 1 divided by 4. And then I can solve it twice. 5 plus 1 is 6. 6 divided by 4 is 1.5. 5 minus 1 is 4. 4 divided by 4 is 1. So 2 real solutions. That's not always going to be the case. So anytime you get a negative number right here, then you're going to have imaginary solutions. All right, so over here, A is 1, B is negative 4, C is negative 12. I'm going to do 2 examples like I did on the last one. Hopefully we're going to see a negative discriminant this time. So negative 4, opposite of negative 4, plus or minus, let me move this, square root of negative 4 squared minus 4 times A times C. Pretty confident this negative 12 is going to make it imaginary. 2 times 1, opposite of negative 4 is 4, plus or minus. Negative 4 squared is 16. Negative 4 times 1 is still negative 4. Negative 4, times negative 12. Okay, that's not going to be what I wanted. Negative 4 times 1 is negative 4. Negative times a negative is a positive. 4 times 12 is 48. Unfortunately, it looks like we're going to get another positive discriminant. 4 plus or minus. Add those together, you get 64. Which is a nice, perfect number, because that's 4 plus or minus 8 over 2, and then you can solve it twice. 4 plus 8 is 12, 12 divided by 2 is 6, 4 minus 8 is negative 4, negative 4 divided by 2 is negative 2. And there you go. All right, I think I'm going to stop there. So thanks again for watching. Hopefully it did help. In the case that you do get a negative on the inside here, so let's say, I'm just making this up, plus or minus, let's say you had the square root of negative 16 over 4. So what you would do in this case, since I'm just making this up, and I'm sort of adding to my video here because I know it didn't happen. So if you get a negative discriminant here, so you got 2 plus or minus, negative square root of negative 16 is really 4i. So, and the reason why it is because 4 times 4 is 16, and the square root of any negatives is impossible, so we use I to represent an imaginary number, square root of negative 1. And then you can simplify and put it into standard form by dividing both these real and imaginary terms by 4. 2 divided by 4 is a half, or 0.5, plus or minus. 4 divided by 4 is 1, so a half plus or minus 1. And if you don't like writing 0.5, you can write literally 1/2. 1/2 plus or minus 1. That was a good example. Thanks again for watching. Have a wonderful day.